in calculus, there are three main mathematical objects. We have limits, we have derivatives, and we have something called integrals. Okay, so limits is all about chapter 1. So we skipped section 1.7 for now. So I think we'll have time later to get back to it, but I decided to make sure that we stay on track first. So maybe we might visit this on Thursday. It's possible. Hopefully we'll have time. Okay. But derivatives is all about chapter 2. So this is what we're studying today. This is today. And then integrals is going to be chapter 3. Or chapter 4, sorry. Integrals is chapter 4. So let's talk about derivatives. And talking about derivatives really takes us back to section 1.4. And section 1.4, we talked about the secant line versus the tangent line. So when we were in chapter 1.4, we saw that the slope of the secant line, that's just between 2 points between it's called AB and XY. We saw that that's just the slope, right? So the slope M is equal to delta Y over delta X. That's equal to X minus Y minus B over X minus A, right? And then what did we see? We saw that the slope of the tangent line is equal to the limit of the slope of the secant lines. This is as X approaches A, right? So this idea is really what all of the first part of calculus is all about. So we sort of introduce it in 1.4, and then we spend a whole bunch of time in 1.6 really looking at how to work with calculations involving the limits. Okay. Now, if you had watched the video, what you would have learned is when we talk about slope of a tangent line, we have to talk about the slope of tangent line at a point. So we could say this is at X equal to A. And you talk about the slope of a tangent line of something. So that's really the slope of the tangent line. Let me move this. Let me say, oops. We're really going to look at the slope of a tangent line of f of x at this point, x equal to a. All right. And I guess it's really important that we're working at this point A, and it's also important that we're talking about a particular function. So what we have is we have a notation that kind of describes this, and that notation is f prime of A. And this is called the derivative of f of x at x equal to A, right? Now, when you watch the video, you see that there's two ways to do this. Two ways. The first way was you take the limit as x approaches A, f of x minus f of A over x minus A. And the second way we have is the limit as h goes to 0, f of A plus h minus f of A over h. And one of these two is better than the other one. Does anyone know which one of these two is better? You could type your answer in the chat box. That's right, Lance. That's right, Kenneth. The second one is better. So I highlight this. This one's better. Now, it's not obvious why it's better until we get to section 2.2. So we'll focus on 2.1 first. But when you're working with 2.2, suddenly you're kind of forced to use the second definition. Okay. When I look at this first definition over here, the nice thing about this is this one looks like slope. This numerator, right, is a difference of y values over a difference in x values. So that looks a lot like the slope. And there's a pretty strong connection between these two guys. So these guys are connected. How are they connected? If you let x equal to a plus h, then what you could see is having a plus h in here going to 0. Sorry, a plus h going to a is the same as h going to 0, right? You can just kind of think about subtracting a from both sides. And then so another thing that you would notice is if you took a plus h minus a, that's going to give you h. So that's why the denominator becomes just h. Okay. This is all explained in the video. I just basically re-explained it to you. But this is what we're working with today. So, you know, I explained all this over there. I did a quick example. This one said, find the equation of the tangent line to this x squared at a equal to 4 using each definition. So I used the slope looking definition over here. And now I want to do the better looking definition. So let's look at definition number 2. So I'm going to take the limit as h goes to 0, f of a plus h minus f of a over h. And then all I got to do is I just need to substitute, right? So, so in this particular case, my a is going to be 4. So let me just copy this thing down here. Okay, and then let's get rid of those a's. Let's change each of those guys to 4. And let's continue this problem. So this is equal to the limit as h goes to 0. We're going to have 4 plus h squared minus 4 all divided by h. Okay. So now we're left with this calculating a limit over here. And really now this is like our quiz question. This is like the type of stuff that I want to ask you on Thursday. So what's the first thing you're going to try when you see something like this? Or at least try it in your head. What's the first thing you would try? Oh, I forgot a squared here. 4 squared, my bad. Anyone? I guess what's the first thing we always try when we want to evaluate a limit? That's right, Jasper. We want to try plugging it in. I call it the direct substitution property. So I hope you guys can see that this is going to be a 0 over 0 type situation. The bottom is clearly 0. The top is going to be 4 squared minus 4 squared, which is 0. So that means, you know, we may be able to solve this guy actually. So at this point, I would say that there's 2 techniques that we could use. Does anybody, what technique would you guys use to evaluate this limit? You could type your suggestion in the chat box. I can think of 2 things I would try. Kenneth says simplify. I think that would be the easiest way. So let's do that. I agree, Kenneth. That's a good way. So we're gonna get the limit as h goes to 0. I gotta FOIL the thing in the parentheses, that first parentheses. So this will be 4 squared plus 8h plus h squared minus 4 squared, all divided by h, right? And then you can see that, oh, I got the 4 squared, the negative 4 squared canceling each other out. That's really good for you. Why is that really good for you? The reason why it's good for you is our whole goal is to cancel this h in the denominator. And when I get rid of these constant terms, every term in the numerator still has an h. That means I can factor an h out. So that means that this guy is going to become, oops. This guy's going to become the limit as h goes to 0 of h times 8 plus h divided by h, like that. And now because I could factor the h out of the numerator, that can cancel the h in the denominator. At this point, since I've gotten rid of the 0 in the denominator, I might as well just try the direct substitution property again. This time when I plug in a 0 for h, I'm going to get an 8 popping out. So my answer is going to be 8. So in either way I do it, I get 8 for my slope. Is there any questions so far about this question? No questions. So I have a question for you. Have we finished answering this question? The simple yes or no would suffice. Are we done? Luciano says no, and I agree, Luciano. The reason why we're not done is because this question actually asks us to find the equation of a tangent line. So this is actually one of our standards, but I probably won't test this standard until later, till we take our test. Yeah, no, Nicholas, because we still need to find the equation of a tangent line. So when you want to find the equation of the tangent line, there's two things that we need. What are the two things we need to find the equation of a tangent line? Point and a slope is correct. Sharon and Luciano. Yes. So we have a point. We need a point. Our point is going to be equal to 4. And just so it's obvious, I know it has to be at 4 because in the problem it's given that a is equal to 4. To find the y value, I simply plug 4 into the function. So 4 squared is going to give me a 16. So we have 16 here. So that's going to be our point. And the second thing we need is we need a slope. The slope is going to be 8. So now we could just use the point slope formula. Y minus y0 is equal to m times x minus x0. I know some of you use the mx plus b formula and you plug in a point, you solve for b, that's fine. I do it this way. So it'll be y minus 16 is equal to 8 times x minus 4. And then when we simplify this, we get y minus 16 is equal to 8x minus 32. So I'm going to add 16 to both sides to get y is equal to 8x minus 16. And that's the equation of the tangent line. Is there any questions about that? All right. Just for fun, let's take a look at this on Desmos. Our function was y is equal to x squared. Okay. The line that we just got was y is equal to 8x. Oh, shoot. 8x minus 16. And the point that we were looking at was 4, 16. Okay, so let me zoom out a little bit. If you could see, I don't know how well you could see, but the red curve is our function. That green dot is the point where we're finding the tangent line. And then the blue line is the actual tangent line that we found. So looking at this picture, it looks like we did it correctly. Just to make sure we all sort of understand conceptually what's going on. If I have this thing over here and I change this to be x squared, and then I make my a point equal to 4. And if I have my h be equal to like 1, it's kind of hard to see, but as I move the h closer and closer to a, we kind of close in on our tangent line. When it totally overlaps, you get 0 over 0. So we're coming from both sides of 0. So this is coming from the left side of 0, and this is coming from the right side of 0. Okay, so I don't know, does anyone have any questions about what we're doing here?